In this episode, we do a complete walk around with last year's top 10 car, as well as covering some specific design principles that allowed this year's team to thrive while manufacturing 100% of their vehicle's parts. We also go over one key strategic move that Omar, the project manager, made that ramped up production in a major way.
And so this is last year's vehicle.
Yeah.
We were,
Check that out. I like that. Yeah, on both sides. Nice.
yeah, we were the second lightest four-cylinder
Wow. Okay.
in the competition. We weighed at, it actually tells you right here at 189.6 kilograms.
No way.
And so it is very light compared to other four-cylinders.
Yeah.
And we do have the full aero, but because we are in the process of validating and dynoing, we do take off the aero package
Okay.
from the
Wow.
vehicle.
So this is just around 400, 425, 430 pounds, something
Yes.
like that. That is crazy.
Yes.
Wow, that's amazing.
So one goal they had last year was to minimize weight as much as possible.
Yeah.
So we did make it averagely shorter than other vehicles.
Okay.
And we did try to minimize on as much possible weight.
So how long do you keep this?
So
vehicle?
we keep it about a year, but like you said, we are limited in resources. So when we start building our car, we'll start taking out the engine, we'll start scrapping pieces off.
Yeah.
But my goal this year is to actually keep it intact. So we are able to actually validate this car as much as possible and also test it while we're still building our car.
Right. Okay.
Yeah.
So in this program, when they say you need to, is that from the race organizers to say we need you to like be lighter than last year's vehicle, or is it internally?
It's internally.
Okay. All right.
It's internally.
So you guys are always wanting to continually improve. That's the goal.
Yes, that is the goal.
Speak my language.
We are trying to always, engineering is always about iterating off of previous designs. And so we grab this design, we grab its CAD, and then we start validating, we start doing calculations to see what we could improve.
Right.
Such as last year, their whole thing was weight.
Yeah.
So if we focus on weight again, there's only about a 5% decrease we could possibly do. And so what are other aspects within the vehicle that we could improve? And so we start optimizing that. We start looking into it through the simulations and through actually analyzing what this car is actually at optimal performance.
Sure, yeah, because you could have a lighter car, but it not have the right downforce, the aero, attributes, and it would perform worse.
Yes.
So it's all a bunch of sliders, and they all do something different. Wow.
Yeah.
So what is your background? What's your story? Did you grow up in the area?
So I grew up in San Fernando Valley. CSUN is a small school, but it's relatively pretty inexpensive.
Yeah.
But they do have a great program like this.
Yeah.
So CSUN does have the resources to make successful engineers.
Yeah.
And so most of our alumni that come from Formula go work at Haas.
Yeah.
And that's the reason. The reason is because, like I said, we're one of the few schools that actually manufacture most of our parts. And so we do have the hands-on experience. That's comparing to other schools who are more theoretically based. And the most they'll do is, yes, they have the same program, but unfortunately they don't have the same resources we do.
Got it. That's fun.
So they sometimes have to send out their parts and stuff like that.
So were you naturally a good student in high school and things like that? Or, did you get good grades?
Yeah, I relatively got
Did you
good
have
grades.
to work really hard?
Yes.
Okay,
yes,
all
yes.
right.
It's always a headache when you come into the lab, but at the very end, it's very rewarding.
Yeah, sure.
And that's because, we, as in the classrooms, I like to tell new people that come in is that when you're in the class, yes, you get taught the basics and you learn from a book, but us engineers like to work with our hands.
Totally, yeah.
And so this is what this program offers.
Yeah.
It gives you that hands-on experience to apply what you learn from the classroom to a real-life project.
Absolutely. Yep, that's great. Hey, I noticed this is somewhat familiar because it's kind of like what we call our Pierson boards. You have everything you need to do. In our in our case, it's the components we make, and then like time-based, and you have all the little tasks, and you have the different phases.
Yes.
And you have these markers that actually look really familiar. I don't know if we gave those to you guys, but yeah. So talk to me about that. Like, that's how it works, right?
Yeah. So it is, like you said, it's a little strategy board. And so most of the time we're doing dyno stuff right now here because we're validating this car.
Yeah.
And so I do put tasks where everybody's going to be able to see it and stuff like that. And every week it does change because we have new goals to set. Because most of the time it does the little markers to reach the end.
Sure.
And so I put it here because, you know, it's not at a fixed spot. And so when people start transitioning into the manufacturing or assembling within the chassis room, I could just pick it up and take it with me.
I love it. Yeah. Again, the working area conforms to how you want to work, not you to it. Yeah. So the goal, like ours, is the same. You want to get all your pins on the right side. Phase 5 done. I love it. Yeah, cool. All right, let's keep moving. All right, so you have a second story.
Yes.
Yeah, let's talk about this. So it's like, feels like engineering alley right here.
Yes. So now we do, this is where suspension and a little bit of chassis work. And so they do have their monitors. They do communicate with each other. So that's why it's kind of in the line.
Sure.
But we do also have our documentation upstairs. So every time, let's say suspension wants to refer back to a previous year, they could just get a folder and look and read through
wow, what an asset. That's incredible. You can go back and, again, what you said earlier, build on like the successes of others. That's great. Yeah.
And then my workstation. So
nice.
Sometimes the team members have to talk to me. And so they'll literally, the first thing they look at when they come upstairs is me.
Yeah.
And that way they don't have to walk all the way down there.
Right.
And just kind of limit the motion.
So I don't know if the project manager always has this desk every year. Is this where they always sit? Okay.
This is where we changed it when we started moving stuff.
Okay, so it wasn't always here.
No.
Okay, so this is a big deal because we're actively engaged in construction to lay out the shop. And for me to answer high-end questions is important, but you need to be removed enough where people don't want to go through the struggle of walking upstairs and disturbing you. But if it's really important, they won't even think about disturbing you. But if you're on the floor, you'll get every little question, you know, and you can't get anything done. So this was like, I don't know if that was your mindset, but this is the place to be for you as a project manager. That's great.
And then I also like it here because if I look over the balcony, I could see the manufacturing.
Absolutely.
I could see Aero, and if I go that way, I could also see what they're doing.
Yeah, that's great.
So we do have one last area, which is our little drive day preparation room.
Okay, yeah.
And so we are in the process of like having this room remodeled to be our little drive day room.
Yeah.
And so we do have our little pit cart that they built last year.
That's awesome.
And we take this pit cart and it has all our tools, anything we might need for drive days or for competition.
Yeah.
Such as the tires and things like that.
Man, it's actually painted and stickered, painted, like clear coated.
Yeah.
You guys did it right. Yeah, that's one of the things like people don't always, and even in business, just because you design a product and it's done doesn't mean it's ready to be sold. You have to have like documentation, carry inventory for spares, that type of thing, marketing, packaging, all that good stuff. So you guys are thinking beyond just the vehicle itself.
Yeah.
I love it. Yeah. Cool. Good stuff. Is someone on the team assigned to be a driver, or do you recruit someone off campus?
So recently it's always been somebody that's part of the driver. The only rule in the competition is that they have to be an SAE member. So we do just keep it internally sometimes, but there is other years that it's not part of the team, but it is like a freshman, a sophomore.
Yeah.
And they're able, if they have enough experience and they're in here in the lab, because to be a good driver, you got to know your vehicle. So if they volunteer enough and they understand and talk to the engine team, to the controls team, then we do allow them to drive the vehicle.
Got it.
That way they could give reasonable or good feedback to the people who are building the car.
So here's my question. Years and years ago, I'll throw a previous team under the bus. They would walk around campus and look for like the jockey type of build of person, like someone small and light, because that was a factor. Is that like, do you do that still?
Yes,
Can you? Okay.
So we still do that. There is, unfortunately, there's height limitations that people don't
Yeah, they
And-
would not qualify.
Yeah, they won't qualify.
Yeah.
But we do have actually a team member that is willing to drive for us, and I'm short, he's light.
That's
and so,
great. I love it.
He's willing to learn and do the acceleration event that we have at Con.
That's awesome. I love it. Very cool.
So this is the upright of the car. It holds all the suspension components.
So really quick, this would have been a model of what I machined for you guys in 2020.
Yes, this is a little bit different.
Yeah.
After we took your inputs
yeah.
about how difficult it was to manufacture your year,
So
we actually streamlined it completely to try to be as simple as possible to manufacture.
So one of the things that the issue was is like it's easy to click like in Fusion, it's the F key and then drop a fillet there. But when you have these fillets that are compound, it's actually, you have to 3D machine those things. And like this angle, yeah, it's an angle. It's obviously something probably round, but in a machine environment, you have to rotate it up like that, or you have to 3D step it across and all that good stuff. So you guys have improved on that.
Yeah,
Yeah,
especially
that's great.
since filling this feature, as well as having this instead of come to here, it becomes really difficult to not hit this feature while also trying to hit this feature and not hit that feature.
Right.
It's been problematic.
Design for manufacturing, DFM. Yeah, that's great.
Unfortunately, in current curriculum, across the CSUs of California and other places around the country, DFM isn't a required course in mechanical engineering.
Is or is not?
Is not.
Is not. Okay. Okay, well.
In fact, I've been trying to make workshops with the students to show them the do's and don'ts of design for manufacturing for milling.
Yes.
Because there's injection molding and turning and all the other things.
Sure. Okay. So most students find out the hard way when they get their first job, and then they design something. It can be made, but it's really, really hard to be made, or it's very expensive.
It's exactly that. A lot of the students that come from here, even though they build a race car, they work at Northrop Grumman or Lockheed or whichever.
Yeah.
And fortunately for those companies, they have the money to not care about DFM, but it still drives the cost of a lot of components very high.
Very true. Yeah, but in a private entity, you'd say, hey, you can't do it that way.
It wouldn't make logical sense at all.
Right.
It still doesn't make sense. They just have the money to just pretend they don't notice it.
Right, and then it takes this, which was, I would say this is probably on the machine. It's maybe call it 4 hours. This is a very complex part, but it could have been like 14 hours with all that surfacing. And I actually asked for permission. Hey, can I just change one thing? And there were things that I changed that were like inconsequential to design. I'm like, they don't need that fillet somewhere, you know? I think like right here, there was a rounded fillet into here, a deburring. And I'm like, they're just gonna get what we give them, so.
Yeah, so specifically for that, part of the cause for that is I would like to call it a newer age of design.
Okay.
Which, because of COVID, exacerbated it, but in the digital world that we moved from 2020, it was all about doing your stress analysis on a computer. So FEA, find the colorful colors on your screen. Red is bad, blue is good.
Yeah.
Make red go away. And the easiest way to do that is to fill it everything.
Sure, yeah. It's literally one click, one edge, one click, yeah.
So when you don't do design for manufacturing at all, and you're taught to get rid of every single stress concentration possible, instead of practicing better design principles, it just filled everything.
Yeah.
And if you can see, you can actually see it from here, from that old upright, which is a 2022 and upright, we made straight.
Oh, beautiful. Yes. Yeah, so this whole thing here goes away. It's just straight. Love it.
And that's and the difficulty too is because this project is a new team every year, it's hard to kind of stress that difficulty between the new generation of students because they didn't experience the misery,
the pain
of the last one.
Exactly.
So it's a lot more difficult to learn and experience you never experienced.
Right. Yeah. Yeah, that's a shout out to this FSAE program in general, because if someone that's watching is thinking of hiring an engineer or like a really great machinist, and that's the path they come up with, like typically you'll just design stuff and you haven't experienced the pain, especially in the Cal State system. It's not a requirement. So it's not a requirement either to be on this team, but it puts them in an environment where they feel the pain, they understand the why, not just being told, hey, do this, do that. They understand why you shouldn't fill it everything.
Yeah, we actually changed a lot from this one. So this one had the tap portion over here.
Yeah, I
this
remember
is a
that.
clearance hole.
Yeah.
Which was difficult because now you had a piece on a vise standing like 6 inches out of the vise.
Yeah.
Then you had you had to have the machine, the tool holder, the tap,
Yeah.
and everything. It was such a very long piece of work.
Right.
Now we made them bolt on.
Awesome.
So now you can see there's tabs here
Oh, sure.
that bolt on to the upright completely.
Yeah, gosh, that's so much better. Yeah, because I remember this. We made this in our UMC, our Haas UMC 500. You know, so we were doing all this. We would then rotate it up on an edge over in place, and we would have a clearance drill, a tap drill, and then a tap, and then you're tapping like you had to have lots of stick out because it had to clear, has to break through here.
Yep.
And it was like, okay, I've made this, and this is 70/75.
Yep.
So you don't want to scrap it. I think you guys gave us like 3 pieces of material, and we had to make 2. And so, you know, in this case, I'm like, okay, we've done all this. If we can't screw this up now, you know, and it was like one of the last things that we had to do.
And it's needlessly difficult.
Yes, yeah, it didn't need to be that way. And same thing with these 2. Or were these? No, one was tapped, one was clearance. I can't, it's been so long.
On this specific one, these are all tapped. On this
Okay,
specific,
these
this
are
is the 2022 year.
Yeah.
This is the 2020, what year is it? 2024 year.
Okay.
So through the years of iteration, it's finally got to a point where it just makes sense.
Yeah.
It's not intensely filleted. It's more simplistic in design and more simplistic in manufacturing, assembly. It's a lot easier all around.
Yeah.
That would give people heart attacks. I won't even know what that would be quoted at a machine shop for one.
So fun fact, this in its machine form was the last thing I ever machined. I programmed it, I machined it, and I retired from machining after that. So, yeah, but it was fun. Now, this video was after the FSAE team did a full tour of my shop. Now, right here is a playlist to that 12-part tour in case you're interested. So until next time, go innovate your production.